Hello, my dear boys. Welcome to my online class. We are discussing a chapter named Effects of Heat on Matter. Today, our topic is specific heat, heat capacity, and fundamental principle of calorimetry. This is a very important topic. Let's start. Okay, our first topic is specific heat. Then the first question is, what is specific heat? The answer is the amount of heat required to increase the temperature of a body of unit mass by unit temperature is called specific heat. I'm repeating, the amount of heat required to increase the temperature of a body of unit mass by unit temperature is called specific heat. Okay, then if an amount of heat Q is required to increase the temperature from T1 to T2, then the specific we can write for specific heat is S equal to Q by M into T2 minus T1. Specific heat is denoted by S. So S, our formula for specific heat is S equal to Q by M into T2 minus T1. I am repeating again, S equal to Q divided by M into T2 minus T1. Here the unit of specific heat is joule per kg per Kelvin. For an example, that we know that the specific heat of water is S equal to 4200 joule per kg per Kelvin. The specific heat of water is S equal to 4200 joule per kg per Kelvin. What does it mean? It means that for 1 kg water, to increase the temperature of 1 Kelvin for 1 kg water, we need 4200 joule heat. Okay, I'm repeating, for to increase 1 Kelvin temperature of 1 kg water, we need 4200 joule heat. Okay, this is our specific heat. Okay, our next topic is heat capacity. Now the first question is, what is heat capacity? What is heat capacity? Our topic is heat capacity. Heat capacity. Okay, I'm writing. Heat capacity is the amount. Capacity is the amount of heat required to increase the increase the temperature increase the temperature 1 Kelvin of a body. So what is heat capacity? Heat capacity is the amount of heat required to increase the temperature 1 Kelvin of a body. Okay. If a mass of a body is m and the specific heat is S, then we can write for heat capacity is C. Heat capacity denoted by C. So if the mass of a body is m and the specific heat of that body is S, then we can write for heat capacity is C equal to m into S. So we can write m for specific heat. We know that it is Q by m into T2 minus T1. So we can write C equal to Q by T2 minus T1. It is the another formula. The unit of heat capacity is unit of heat capacity is joule per Kelvin. Unit of heat capacity is joule per Kelvin. Example. Okay. Example. The heat capacity of we know that the heat capacity of water is 4200 joule per kg per Kelvin. So heat capacity of 10 kg water is Cw equal to 10 into 4200 joule per Kelvin. So we can write 4200 joule per Kelvin. Again heat capacity of heat capacity of 10 kg gold is C equal to 10 into, we know that the specific heat of gold is 230 joule per kg per Kelvin. So 230 equal to, we can write 2300 joule per Kelvin. From this calculation, we can see that the heat capacity of gold is more such as 20 times less than the heat capacity of water. We can see from this calculation that the heat capacity of gold is near to 20 times less than heat capacity of water. So we can say that gold can be heated quickly. Gold can be heated quickly than water. So we can say that gold can be heated quickly than water. Okay, this is our topic's heat capacity. Next, we will discuss about a important topics, most important topics on this chapter, and that is the fundamental principle of calorimetry. Let's. Now our topic is fundamental fundamental principles of calorimetry. Calorimetry. We know that heat passes from one place to another place. But our question is where to where? Okay, we know that heat passes from high heated place to lower heated place. Okay, so we can discuss about fundamental principle of calorimetry with two conditions. The condition number one is the body of higher temperature. The body of higher temperature gives heat to the body at the lower temperature until they reach thermal equilibrium. Okay, the body of higher temperature gives heat to the body at the lower temperature until they reach thermal equilibrium. And the number two condition is number one is I'm repeating again. The number one is the body of higher temperature gives heat to the body at the lower temperature until they reach thermal equilibrium. And number two condition is the amount of heat given up by the bodies at higher temperature will be equal to the heat gained by the bodies at the lower temperature. Okay, mainly this condition is our fundamental principle of calorimetry. Okay. The fundamental, so we can say that the fundamental principle of calorimetry says that the amount of heat given up by the bodies at higher temperature will be equal to the heat gained by the bodies at the lower temperature. Okay, okay, I'm repeating. The amount of heat given up by the bodies at higher temperature will be equal to the heat gained by the bodies of lower temperature. So, at a line, we can say that for fundamental principle of calorimetry, we can write in a word. For fundamental principle of calorimetry, we can write that heat given up equal to heat gained. So this is our fundamental principle of calorimetry, and that is heat given up equal to heat gain. Heat given up equal to heat gain. Okay? Okay. Now I will discuss about another important topics. Okay. We know that matter have three states. One is solid, liquid, and vapor. Okay, we have three states of matter, and number one is solid, two water, and three is vapor. Okay, so if you melt a ice of -7 degrees, suppose if you want to melt a ice of -7 degrees, then by gaining heat, it will turns into liquid, and then gain more heat, it will convert to vapor. But it will not only three stages. It follows four stages, because the ice is not directly convert into water. The ice firstly convert into the 0 degree temperature ice, then it will convert into 0 degree temperature water. Okay, then 0 degree temperature water increases its temperature, and by increasing temperature we will get 100 degrees Celsius temperature. Then 100 degrees Celsius temperature converts into 100 degrees Celsius vapor. Okay, so here we have some steps. Let's see. So if we get a piece of ice of temperature -7 degrees Celsius, then for first step it will convert firstly the 0 degrees Celsius temperature ice. Okay, and 0 degrees Celsius temperature ice converts into 0 degrees Celsius water. Then 0 degrees Celsius water converts into 100 degrees Celsius water, and 100 degrees Celsius water converts into 100 degrees Celsius vapor. Okay, in this stage, the stage where it changes its stage. In this stage, it gain a heat, and this heat is called latent heat. Okay. In this stage where it changes its stage, this on this stage it's gain a heat, that heat is called latent heat. If it convert into ice to water, then this latent heat is called latent heat of ice. Okay, and it is latent heat latent heat is denoted by L, and for this stage the latent heat is 336,000 joule per kg. Okay. On this stage where it converts water to vapor, in this stage it also gain another latent heat. This latent heat is called latent heat of vapor, and it is denoted by LV. It is denoted by LF, and it is denoted by LV, and the value of this latent heat of vapor is 226,000 joule per kg. Okay. In this stage, it will follow its natural formula, and the heat gain is Q equal to MS ice. Here the stage is ice, so the specific heat of this stage will for ice T2 minus T1. Here it is T1, and it is T2. For this stage, the formula is same, Q equal to MS. In this stage, it is water, so specific heat will be for water, so MSW. Here also T2 minus T1. We will try to use here for temperature, we will try to use Kelvin temperature for temperature. Okay. In this stage, the heat is MLF. In this stage, the heat gain is MUV. Okay. Okay. So this theory is very important or very useful for solving the mathematical problem on fundamental principle of calorimetry. So you need to study these topics very carefully. Okay. Okay. So this is all for today. Until then, in our next class we will try to solve mathematical problem, because our theoretical part is come to an end. So in our next class we will try to do some mathematical problem. So until then, thank you boys.